Unit 3-1, air masses and fronts. Air masses. An air mass is a batch of air that is nearly the same temperature and humidity. It is created above an area of land or water, which is known as the source region. For us in Iowa, we have four main source regions. So air masses are just air that has the same temperature and humidity. When you talk about we have cold air coming in, or we have dry air coming in, or hot and wet, or hot and cold, we're talking about different air masses. And it all depends on where our air is coming from. It's coming from the north, it's coming from the south, it's coming from the west. Even if it's coming from the south, it's coming from southeast, southwest. Where that air is coming from is going to determine what type of weather we get. It's going to determine what type of air we get. Now, there are four main air masses that affect us. Continental tropical, which is dry and warm. Continental polar, which is dry and cold. Now, first off, continental means dry. Tropical means warm. So, dry and warm is continental tropical. Polar means cold. So, continental polar is dry and cold air mass. Maritime means wet. So a wet warm is maritime tropical. A wet cold is maritime polar. Now, dry warm air for us is going to come from Mexico or Texas region. The dry cold air for us is going to come from Canada. It's going to form over, because it's dry, it's going to form over a landmass. If it's wet, it forms over water. So wet and warm will typically for us either come from the southern Pacific or the Gulf of Mexico. More likely, a lot of times, it is the Gulf of Mexico. In the summertime, our humidity is pretty much driven by the weather from the Gulf. And I'll just write South Pacific. The cold air mass, which is also wet, that's going to come from the North Pacific Ocean. So it's air mass that's going to come near Washington State and head east towards us. So you see the main four: continental polar, continental tropical, maritime tropical, maritime polar. There's also continental Arctic, and there's another air mass which we can worry about near the equator, but these are the four that come to us. So continental polar comes down from Canada, or continental tropical comes from Texas and Mexico. Maritime tropical can come up from the Gulf of Mexico mostly, or from the South Pacific, and then typically we see this air mass for our maritime polar. Now, when two air masses with different temperature and humidity meet, we call this a front. You can think about the term that came from talking about wartime. We had two opposing forces meeting together. That was called the front. Well, the same thing with air masses. They're almost doing battle in a sense. Ordinarily, when fronts meet, one air mass is lifted over the other, which creates a low pressure zone. But the fronts usually have winds. With the higher temperature difference, the higher the winds. Now, cold front. This is when cold air mass takes the spot of warm air mass. And really, I normally like to say it shoves out the warm air, because the cold air is denser, which means it's going to stay closer to the ground, where the warm air is less dense. It naturally wants to rise. So this will be a very drastic change. And so you see a very drastic change here where the two fronts meet. And this oftentimes forms those big cumulonimbus clouds, a lot of precipitation. We won't see much in the way of clouds or precipitation ahead of this. This is a very sudden change. Now, if you look at the bottom of the little picture there, you'll see what the symbol is for a cold front. Cold front is a line with blue triangles on it. And the triangles point to the direction where the front is moving towards. So the triangles point the direction the air is moving. This will be behind the front. This is in front of the front. Opposite of a cold front is a warm front. When warm air slides over an existing batch of cold air, there's a warm front. The symbol for this one is different. Again, because it's warm air, we're going to use red as a color. Instead of triangles, we use half circles. And again, this is in front of the front. This is behind the front. And so it's when warm air slides over existing batch of cold air. Again, warm air is less dense, so it'll gradually push out the cold air. You'll see a lot of cirrus clouds forming up high along the warm front, and then those clouds will thicken as the front passes. and we could see precipitation falling. This could last a lot longer than the cold front. The cold front's going to be a very drastic change. It's going to be a more powerful storm, but it's also not going to last as long. A warm front can still bring storms, but they'll be lasting a little bit longer and tend to be a little weaker. A stationary front is when two air masses meet, but neither moves. So you can have a cold air mass next to a warm air mass. They're not moving each other out of the way. If you look down here, you can see the symbol. The symbol for this is triangles on one side, the half circles on the other, and they're red and blue. So they are their normal colors. Stationary front, and you can see which way the two fronts are kind of heading, but they don't push each other out of the way. But a region underneath the stationary front could experience days of rain, drizzle, and fog, and it could cover a very wide area. An occluded front is the fourth type of front. It's pretty much where we have two cooler air masses trapping below a warm air mass. You can see this occluded front right here. You have very, very cold air, not as cold air, and this is warm air that's trapped above it. So it's kind of three air masses meeting. This is the third one coming in. So this will be kind of the first. This is the second. And here comes the third air mass to come in. And you see the motion here from left to right. You see the symbol. They're on the same side now. This could trap it. Of course, we can get precipitation here. We can see our clouds forming. As the air comes in contact with cold air, warm air comes in contact with cold air, then that's where we're going to see our precipitation. Now, these are the four symbols again for a warm front, cold front, stationary front, and occluded front. Typically, the occluded front will be purple. And I'll show you a picture of that right here. So we have a cold front here, a warm front here, and you can see that this is the occluded front. So the warm air got trapped beneath cold air. If you're a town right here, what you would expect as weather is that since you're that close to the front, you're probably already seeing clouds. You're going to get storms probably occurring soon. And you're going to see a very drastic temperature change. Also, as all the fronts move past you, you will typically see a change in direction of wind, depending on what type of front it is. So this front is moving this way, this front is moving that way, and this front's kind of moving that way. So if you're right here, you just had the warm front pass over you, and you're going to have a cold front. Now, when you see a situation like this in early summer, this could actually be a situation that causes a lot of severe storms. Typically, the greater the change in temperature, the stronger the storm. So if you see we are in the 90s one day and it's going to be the 60s the next, that's going to be probably a very strong storm that's causing that. So fronts allow us to figure out what's going to happen. And we identify fronts by just looking for where the air mass is changing by a lot. So this is the front, and then we move across. And this is the easiest way to predict our weather. We just look where are the fronts. Do we have cold air coming in? Do we have warm air coming in? How much is it warm, dry air? Is it warm, wet air? If it's warm, wet, then we can expect some storms. If it's warm, dry, we're not going to see the storms. So by identifying the air masses, identifying the fronts is the easiest way to predict our weather.